Hey there, this is a continuation of the composition of functions video. So we're going to do example 2, let f of x be 1 over x and g of x equals x plus 3. And we have three things. We're going to find the sum of the two functions and then the combination, the two different ways that we can do the combination. So first though, let's talk about the domain of each. So for f, notice that the domain x cannot be 0. You can't have 0 in the denominator, so the domain is going to be all real numbers except 0. So it's minus infinity to 0, not including 0, and 0 to infinity. And g of x, the domain for g, is all real numbers because this is a polynomial, right? The domain is every x value for which the function is defined. Nothing makes this function undefined, so the domain is all real numbers, minus infinity to infinity. So when we go find the sum of the functions, so f plus g of x means f of x plus g of x. So I'm going to have 1 over x plus g of x, x plus 3. And so we can think of this as over 1 and get a common denominator. So the common denominator is x, so multiply top and bottom by x. And now simplify. So I'm going to have my common denominator is x. I'm going to have 1 plus, distribute the x squared plus 3x. So my f plus g then is x squared plus 3x plus 1 all over x. And so what is the domain of this function? Right, the domain, notice that it is x can't be 0 again. But as in the previous example and in your book, it says the domain is the domain of f intersect with the domain of g. Right, so if I call this A, it's the domain of f, and B, the domain of g, the domain is the intersection of the two. So if you take minus infinity to 0 union 0 to infinity, and you intersect this with minus infinity to infinity, you're going to get, essentially you're excluding 0 still. So the domain is minus infinity to 0, union 0 to infinity. So that's looking at it as the intersection, but you can also just go over here and say, well, I still have x in the denominator, so x can't be 0. So the domain, I can just go directly from here and say x can't be 0 and go directly to it. Now for part B, we want to find the composition of functions, f of g of x. So that means f and g of x is the input. So this is my input, and so let's go find what that is. So f is 1 over x and g is x plus 3. So for part B, f of g of x is going to be 1 over g of x, which means 1 over x plus 3. And what is the domain of this function? Again, we have a denominator, so we don't want the denominator to be 0. So our domain is going to exclude all values where x plus 3 is 0. So that means when x is negative 3. So we will exclude negative 3. So that means that the domain is all real numbers except negative 3. So that means minus infinity to minus 3 not included, so parentheses, union, then minus 3 not included to infinity. So you want to say all real numbers except minus 3. So you put parentheses around that. What about part C is g of f of x. Now f of x is the input into g. So g was x plus 3. So I'm going to have my input, f of x, plus 3. Right? Since g of x was x plus 3. So you replace the x. The x is the input. And so what was f of x? F of x was 1 over x plus 3. And again, you can get a common denominator here and of x. So you can put a 1 under the 3, right? Any whole number, you can just put a 1 under it and make it a fraction. So multiply it by x, and so this becomes 1 plus 3x, the whole thing over x. And the domain, in this case, we want to exclude all values where x is 0. So the domain will be minus infinity to 0, not including 0, and 0 to infinity. So let's try another example. Example 3, let's make it slightly even more complicated. Let f of x be the square root of x plus 3, and let g of x be x squared minus 6. So as soon as you see a function, what I want you to start thinking is like, what's the domain of this function? What values of x are we allowed to plug in? And for this one, we're just going to find the composition of functions. So let's find, let's say, f of g of x. So, but let's look at the domain. So for this one, the domain of f, I know, okay, I have a square root. So square roots should ring a bell, right? Red flag. Okay, we can't take the square root of a negative number. So that means we want x plus 3 to be positive. So greater than or equal to 0, right? The square root of 0 is 0, so it can't be equal. So that means we want x to be greater than or equal to minus 3. So then the domain in interval notation will be -3, and I do include it because it does have the equals there, all the way to infinity. So that's the domain of f. What about g? The domain of g, is there anything that will make this function undefined? No, this is a polynomial, so nothing makes it undefined, so you have minus infinity to infinity. Right, the things to watch out for are radicals, especially square roots, even radicals, because we can't take the even radical of a negative number in any time you have denominators. Later on, we're going to talk about logarithms, and logarithms are another type of function to watch out for. So let's find the composition. So f of g of x, f circle g of x means f of g of x. So my g of x is the input. So what does this become? So this will be f of x is the square root of x plus 3. So everywhere I see an x, we're going to put in g of x. So g of x plus 3. And substitute what g of x is. G of x is x squared minus 6. So this becomes the square root of g of x squared minus 6 plus 3, which is the square root of x squared minus 3. And so now how do we find the domain of this? So I have my composition of function, and notice that we still have the same thing, that we have an even radical. So for the domain of the composition, we want x squared minus 3 to be greater than or equal to 0. And so this is a higher order inequality. So we have to be very careful about how I solve it. And it's not quite a difference of squares, but you can still think of it as if it was a difference of squares. So what am I squaring to get 3? And in order to get 3, you're squaring the square root of 3. Right? So that means that this factors into x minus root 3, x plus root 3. Greater than or equal to 0. And this is where we do the test point method. So think about, for example, what if, so big if this was x squared minus 4 greater than or equal to 0, what would this factor into? Right, this would be x minus 2 and x plus 2. Because what are you squaring to get 4? You square 2. So 2 times 2 is 4. So that's the same thing that's happening here. What am I squaring to get 3? root 3. So root 3 times root 3 gives us 3. So plot our zeros. So I'm going to get negative root 3. Negative root 3 make this term 0, the second term. And the first term is positive root 3, makes it 0. So that's where you have the zeros. And it is included, so these are going to be solid. And now we pick our test points. So our zeros break it up into 3 regions, 3 intervals, right? You have your minus infinity to minus root 3. That's this region. The middle region is negative root 3 to root 3. And then the other region is root 3 to infinity. And I guess we are including these. So those should be brackets. And so let's pick values, test points to see what it looks like. So test points, and remember we want positive. So greater than 0 means we want the product to be positive. So let's pick our test points. So something in between negative infinity to negative root 3. Negative root 3 is something between negative 1 and negative 2. So I can pick x equals negative 2. And let's plug it in. So I'm going to have negative 2 minus root 3 and negative 2 plus root 3. Now this is going to be, that's a negative number and that's a negative number. Negative times a negative makes positive. So that's positive. So do we want that? Yes, we said we want the product to be positive. So I will shade that. And let's pick another test point. Something between negative root 3 and positive root 3. Be nice to yourself, pick 0. When x is 0, you're going to get 0 minus root 3 times 0 plus root 3. Right? You're plugging it into your product. And this is a negative. We get a negative times a positive, which is a negative. We don't want that. We want the product to be positive. And so let's pick another test point, something larger than root 3. So I'm just going to go with 10. Doesn't matter, right? So as long as it's bigger than root 3. So 10 minus root 3 times 10 plus root 3. So notice that here we're going to get a positive times a positive, which is positive. And we are looking for positive, so we're going to shade that. So what this says then is that our composition of functions is f of g of x plus the square root of x squared minus 3 with domain. What did we get? We want to be able to see that number line. Minus infinity to negative root 3 bracket, because we're including it, union, and then positive root 3 to infinity. So we skip that middle, negative root 3 to root 3. Okay, so that's how you find the composition of functions and the domain also of the compositions of functions, and it kind of helps us review a little bit of how do you find the domain of something. So a good problem to try on your own is find, what about g of f of x, and find the domain. So try that on your own and email me for the answer.